I am Benila. In today's video, I am going to talk about the Mori loop test. In my previous video, I explained the three types of faults that are likely to occur in underground power cables. Open circuit faults occur due to broken conductors. Short circuit faults occur due to insulation failure. And earth fault occurs when the cable is torn. Since the underground cables are buried, if the fault occurs, it is invisible to our naked eye. By measuring the resistance, we can identify the faulted cable. Yes, we can find which cable has a fault. However, we cannot identify the exact location of the fault. There are several methods for locating the fault in underground power cables. In this video, we are just concentrating on the Mori loop test. This is used to locate the earth fault and short circuit fault. It uses the principle of the Wheatstone Bridge. So, before explaining the Mori loop test, let me just go through the Wheatstone Bridge. The Wheatstone Bridge is a diamond-shaped circuit that can be used to measure unknown resistance. A Wheatstone Bridge consists of four arms, which consists of known resistance, unknown resistance, and variable resistances. The circuit also consists of a battery and a galvanometer, which is an instrument used to measure the current. It gives zero deflection when no current flows through it. We have balanced and unbalanced condition in this Wheatstone bridge. The bridge is said to be unbalanced when the current flows through the galvanometer and is said to be balanced when no current flows through the galvanometer. In the balanced condition, the ratio of these resistances will be equal. Therefore, a balanced condition can be achieved by adjusting the variable resistances. Now, let's see the Mori loop test. We have two cables here, cable A and cable B. Consider an earth fault on cable B at point F. Now the challenge is to find the point F without digging the whole cable out. For that purpose, the Mori loop test is used. Let's first draw the circuit diagram. We have two cables, A and B. At point F, we have an earth fault. The resistance of the cable A is considered as R. This value is normally given by the manufacturer. Since the cable A is similar to cable B, the resistance, area and length will be approximately equal. Therefore, the resistance of the whole cable B is R. Let's consider the cable resistance value before the fault point as R1 and after the fault point as R2, where R1 plus R2 gives R. As I mentioned earlier, the Mori loop test uses the Wheatstone bridge principle. For that, we need that diamond-shaped circuit. So, we first need to join the far end of the cables using a low resistance link. Now we have two arms of the bridge. We need two more resistances, a galvanometer and a battery. They are connected to the near end of the cables. The values of P and Q are adjusted so that the galvanometer shows zero deflection. Now it is balanced. Therefore, P by Q is equal to R plus R2 divided by R1. If you add 1 on both sides, we get P plus Q divided by Q is equal to R plus R2 plus R1 divided by R1. We know that R1 plus R2 gives R. Therefore, P plus Q divided by Q is 2R divided by R1. Here, P, Q and R are known values. By substituting these values, we can find the unknown resistance R1. If we know this length, it is very easy to locate the point F. Let's consider this length be D. Then the fault is D distance away from the near end. How to find the distance D? We know the resistance of this part. We also know that the resistance is proportional to length. R is equal to rho L by A. Therefore, R1 is equal to rho D by A and R is equal to rho L by A. Now, if we divide equation 1 by 2, we get R1 by R is equal to D by L. From this, D is equal to R1 by R into L. If we substitute the R1 value here, we will get the final equation for D. With this D value, we can locate the fault. This is for an earth fault. Now let's see how to locate the short circuit fault using the Murray loop test. This is very similar to an earth fault except that the battery terminal is not grounded. It is connected to the cable which is faulty. Here also the bridge is balanced by adjusting the P and Q. The position of the fault is located using the same calculation that we did earlier. Now, can you guess the limitation of this fault? Without the presence of cable A, we cannot locate the fault in the cable B. In other words, the Murray loop test can locate the earth fault or short circuit fault in underground power cables provided that a sound cable runs along the faulty cable. Now imagine a trench with only one cable. If the earth fault or short circuit fault occurs in this cable, then we cannot locate the fault using the Murray loop test. That's all for today. Bye. See you in my next video.